All right, now let's generalize our conclusions here. Before we looked at average velocity and instantaneous velocity. Now we're going to look at average rate of change and instantaneous rate of change. Now a lot of this is a repeat from what was in, I think it was 2.1, where we introduced the idea of a limit. Okay, so I'm going to leave a lot of this to you to read, but if you recall, the average rate of change is the change in y over the change in x between 2 points on the function, right? And so it's the slope of a line segment connecting those 2 points. That's the average rate of change. Now, if we let those 2 points get closer and closer together, what we get is the average rate of change, or sorry, the instantaneous rate of change. And it's the limit as those 2 points get closer and closer together. And then what we have is instantaneous rate of change. Now, this is a repeat of what is in the beginning of chapter 2. So the new thing here, now we did talk about the derivative at a point, but now that we have limits under our belt, these are the new things here that, these two definitions of the derivative, right? We said at the beginning of chapter 2 that the derivative is the instantaneous rate of change, okay? So now that we have limits, we've got these two formulas, right, here. So we can either take the average rate of change, right, from x, from a to x, essentially, some arbitrary point x, and then let x get closer and closer to a. Or, and this one is important because this is probably the more frequently used formula that we're gonna see. And so in this case, h is just a small amount, right? So what we're doing is we're finding the average rate of change between a and a plus a little bit, right? A, could be, or a might be 2, and then a plus h might be 2 plus 2.1 or 2.01 or 2.001. So h is just a small amount. We're just adding a small amount to the value that we're trying to find the derivative of, right? So these are the two formulas that we're going to use to calculate the derivative at a point. Okay, so again, the derivative is the instantaneous rate of change. It can also be thought of as the slope of the graph at that point, or the slope of a tangent line at that point. Okay, where a tangent line is just a line that touches the curve at that one point. Okay, so if f, this is again a repeat of what we covered before. If f is increasing, then the derivative is positive, right? Because it's slope. The slope is positive if f is increasing. And if f is decreasing, then the slope is negative, right? Because the slope of the tangent line is negative. All right. So we're just going to make sure you understand what we just talked about here. And so here we're shown a graph. The blue is our f of x, right? This is f of x. And then this is f of x, and this is the tangent line. Okay, so it shows a tangent line at a particular point. So this is the tangent line. Okay, now it's asking us to find f of 3 and f prime of 3. Remember, f prime is the derivative. So f of 3 is just the value of the function, right? If we're looking for the value of y when when x is 3, all right? So now we don't have a formula, we just have the graph, and we can read it off of the graph. So when x is 3, it looks like, here, I'll just draw a little dash line. When x is 3, y is 2. So f of 3 is 2. All right? Now, f prime of 3 is the slope of this tangent line. So we had to try to figure out what the slope of this tangent line is. So I'm just going to, given that it's a line, I want to find the rise over the run of 2 points. And it looks like, let me scroll up just a hair here. It looks like I can see here that it's going, it looks like it's going through the point 2, -2. And then it's obviously going through the point, this is the point 3, 2, right? And this looks like it's the point 2, -2. All right, so what's the rise over run? So I'm going to look at the rise. The rise, I'm just going to go straight up, right? And it looks like, now, excuse my crooked line, but you can see I went up 1, 2, 3, 4 units. And then over by one unit to get from one point to the other, right? So that tells me that the slope, rise over run, is 4 over 1. So the slope is 4, all right? And remember that the slope of the tangent line is the value of the derivative. All right? I'll meet you in the next video.